Okay, so this time we're going to look at the feedback we got from Boeing. So on the left-hand side, we have our slides, and on the right-hand side are my handwritten notes. So this is a little bit hard to read. So I don't remember the slide. I forgot to write the slide number for this question. But yeah, so this is the first year that your school, UH, is entering competition. And then last year was preparation for competition. So yes, this is our first time. They also asked if we have a definition or some information about the competition for these tasks. So we've mentioned the rules, things like that, but we should have like been more explicit about defining them. And let's see. Yeah, that way he doesn't need to know, or that way, so I don't need to know about the competition, but we need to know the rules later, right? So that's really important. So one of their engineers told us complete and compete. That's a good formula and mantra. I mean, one of the formula teams, that was their mantra, complete and compete. So he agrees that we should just focus on the primary task just to start our competition participation. We were asked to locate targets within a 75-foot radius, what's your coordinate system, and how big are the targets. Very important details that, again, I believe we mentioned at the project proposal. It's good to mention those things for context. And so we were asked on, okay, now this is slide 33. So over here. So if we're in payload capacity, is lift really a concern? So, I mean, the answer is not really. Then the question is, or do you use the other drone, the bigger one, right? The Anaconda. And so if you remember on slide 30, we talked about the Anaconda's got an 8.81 pound payload capacity, whereas Penguin, the one that we got, only has about 2 pounds. Okay, so the other question we're asked is on slide 35 here. This is about the payload table. So here we're asked, does this include the wires and the glue? And the answer was no. And then we looked at what happens and what's the likelihood if you exceed the payload capacity, because right now we're at 1.9. And if you remember, we had 1.98. So that's pushing it pretty close, right? Just 0.08 pound difference. And so the question was, is there a consequence if you go a little bit over? Is that okay, like 5%? And then people were asking us, is it okay? And we all agreed together as a team to buy the bigger drone, the one that can carry more payload. And then there's a question, is there a penalty if you switch to different aircraft? Like, do you have to pick the Penguin and then you like tell the competition people and the judges, like, we're flying this one, you switch? Is there a problem with that? That was our question. We were also asked that if we're short money, do we do like a donut or car wash fundraiser? And because overall it's just comforting to have something with larger payload capacity, right? Because again, you have like 0.08 pounds remaining. That's really small. Not a lot of margin there. We don't know what the manufacturer limits are. They could be maybe underestimating, so we're not too sure about that. And it sounds like we're concerned with pennies and finances, things like that. And then we're also asked, like, do you know enough about other platforms, right? See if the integration is affected. So other teams, they bought another kit drone, they threw electronics in, they could do the competition. Are they still going to be good to go? So that was the first page of notes. And here's the next page. So we said, do you know like the total what the total wooded area is? Then you can get the Reynolds number. And then there's charts about how do you look at the skin friction. This is going to go back to our question that we had, I think on, I write the slide number on this one, did I? Looks like I didn't. But this is probably about the drag. So this is probably on slide maybe 37. This is probably when they asked that question. We also asked another part of mitigation, are there integration issues with choosing another drone? What are those limitations of the other kits? So this is probably when we're on slide 29. This might not have been in order for some reason, or they just wanted to go back to the slide. So on slide 30, we didn't really talk about the limitations too much. This is, again, not a very good DMM, as we said last time. And then on slide 41, we were asked, why did the team reinforce the Anaconda with carbon fiber? So I think anecdotally, there's a team last year or something. They had an anaconda and they reinforced it with carbon fiber. So the question was, why would they do such a thing? And then we were also asked if that team at competition last year or whatever, they asked us, are they adding other attachments? And then we were also asked, are there issues with camera stability and then picture resolution? And then we were also asked, if you're building your own drone, then you should consider like ease of build and cost. So this might be on, oops, sorry, let me scoot this over. Slide 40. So I put on, I erased that one, I guess. This is still slide 41. I guess we're just stuck on this slide, but they asked a lot of questions that came to their mind. Not particularly on this slide, though. And then we're also asked, is there an advantage of having a custom drone? Like, do you have to have one that you built with your own hands? And if there's any teams that built their own drone. We're also asked, what kinds of points scoring do you get if you build your own drone? I think the answer is you don't get any bonus points at the time, but I'm not sure how we answer that question. Okay, then on slide 50, let's go to 50. We were talking about the software. And so we're asked if there's like a difference between post-processing and while you're doing that mapping, that search area task, you do that lawnmower pattern. So we're asked if the zoom and the angle you pick are within the 25% of the 75 feet or 25% or more of the frame. And then we're asked, how are you storing the pictures? The answer was, yeah, we put on the SD card of the camera. Will you run a battery? Fortunately, we didn't, but it's a good question. I guess we did mention how big that search area is. It's 8 square or 8 million square feet. I guess we mentioned it verbally, but not explicitly on the slides. We were also asked, can you cover more area if you just have a high resolution, but you fly higher? So, I mean, theoretically, yeah. Um, I guess didn't write down this last part of the question. We're also asked, like, when's the competition? When do seniors graduate? Because at this time, I think they're starting to get worried that this is a lot to take on. So we want to make sure knowledge transfer is not an issue. Okay, on slide 61, we were also asked, are all of these done in static conditions? So the answer is yes. We just did a static motor test. And then we're also asked, what does the flight time look like? Because if you do something here, it's going to be very different. You put it on the actual drone and fly it. And so that's going to affect your mission plan. And we didn't really explain the mission plan. So that's the second page of notes. Let's go to the third page. So we're also asked, have you figured out where everything fits inside? And the answer was, I don't think the answer was yes. I think we're still trying to troubleshoot and figure that out at the time of this presentation. On slide 66, let's see. We were also asked, how do you send images down? Like, do we send it wirelessly? And we said that we store them and we process them on the ground later on. And then on 67, we were asked, is there a time limit for doing the data transfers? And is there a takeoff and landing time? Like, can you go up once or twice, come back? Because then you can like take a bunch of pictures, you pull the SD card, down into the computer, put it back on the camera, put it back on the drone, then take off again, and then continue where we left off. That was why they asked that question. They also asked, you can use floating analog. The previous teams do that. You can't crash. UW have a tank thing. I forget what this means. We were also asked about navigation imaging. Can you find rapid ways to develop images and then in parallel develop something where you can test with a different vehicle? Yeah, that's a lower risk. You can have like a fixed wing navigation and a fixed wing autonomous testing. So you can have maybe two penguins because if you have so much money, you can buy another penguin and test in parallel. It's a good idea. And we did buy more kits just in case we crashed, which we did. Okay, on slide 73, we're asked what does flight termination look like? This is a really big deal. So we had to explain like you flip a switch in the controller and then communication is temporarily gone and then the drone needs to do different things. So we have to explain that in more detail. We're also asked when you're approaching a boundary, what do you do? Like that red no-fly zone, what happens? Do you have to turn? Because you don't want to just keep going forward, especially if you're a plane. You can't just stop and then turn like that, right? We're also asked, are there expectations for payload security or external attachments? And if the aircraft loses an important component, does it immediately shut off or terminate? And then it looks like we didn't finish the rest of this question. With a commercial off-the-shelf and payload something something. Okay, I forget what that one was about. On slide 77, they were asked the definition of PDR because we weren't really at a preliminary design review yet. We had a lot of details and data missing. And by CDR, we hope to have all the details. And we were also asked that we need to have some point in our timeline to have testing and to have major milestones and refine and test all those things in parallel. You have some integration phase where everything comes together. Make sure you give enough time to debug and refine, especially if you have to do any design modifications for either drone kit that you buy, the Penguin or the Anaconda. And then we're also asked, is this Anaconda drone even available? Because it looks better than the Penguin, the one that we bought. And then we're asked, if you have to switch from the Penguin, when do you do that? When do you put that on the Gantt chart? It's got to be some critical point in the timeline. And then we have to create some critical decision points and milestones. We're also asked you can maybe do a flight simulator on the PC, which we end up did getting. I think we got Real Flight 7 or Real Flight 8. So come with the controllers, so you can hook it up to your computer by USB, and then you can pretend to fly a drone on this mock game like structure. And see slide 80, we were asked, oh, just comment, Boeing money goes only to technical aspects. So we couldn't use it to go to competition because it's not a technical thing. If we were going to buy hardware, software, licensing, then that would be fine. Okay, so that's the end of the third page. And then the last page of notes. So overall, we were told by them they like the VIP plan, the vertically integrated project. It's very fantastic because it has this multidisciplinary aspect. They like the idea of us completing just those two primary tasks and then just worry about the secondary tasks later. They're enticing. But you told us that we'll learn more by just compete and complete. And they said, yeah, looks pretty good. Looks great. And another person, they told us, yeah, cool project, include a technical risk too. We kind of didn't mention that. And our risk cube wasn't really good. So if you remember here on slide 79, we did risk mitigation for project management. We didn't do it for each subsystem. So he was expecting us to do that. He also wanted us to try to think and pick small integration points, so have some brief milestones there. And then you have some parallel validation of like this task and that task. And then you can see all these parts working together. He also wanted us to think ahead of some integration point. So after you have all these different pieces working together, I mean, after you have all these pieces working separately, at some point in time, you need to put them all together to make sure they still work together. That's going to be really important. And that way it forces, oh, and then you need to do that so you can foresee some roadblocks and different problems, things like that. And those are all the comments we had from our Boeing friends and engineers.